we do this. So I'm going to erase it now, do one more question with you guys using midpoints. So I know you guys really enjoy doing midpoints. Midpoints get a little bit trickier since you have to do another step in between right and left. So you just look at the interval, use the point. Pretty good stuff. So I'm going to write down the question, of course, then you can pause the video and just do it on your own and check my answer afterwards. So f of x, make that x, is equal to the square root of x plus 1. Nothing too hard yet. Neg 1 to x to 0. So neg 1 is is less than to equal to x, and x is less than or equal to 0. So that is your upper lower limit of integration. I want you to use a Riemann sum using 4 subintervals. So 4 subintervals, and as I said before, a midpoint. So midpoint, just using midpoints. So use midpoints. Midpoint on Riemann sum. So you can pause it right now. I'll pause it right now as well, and you can tell me the answer after you pause it. So okay, hopefully you did pause it there, and we are going to go straight into the solution here. So we're using midpoints, and we have 4 subintervals, so we have a n equals to 4. And remember, this one you really need to draw out the number line. Draw it out. This is the only way you're going to visualize it. So you're going to go from neg 1 to 0, okay? And let me just draw this a little bit more straight for you. Maybe let's extend it a little bit more, get some more real estate on this, because this one's going to have 4 subintervals. But as you can see, we're going to go from neg 1 to 0. The only number in between here is 1. It's going to be neg 1 half, right there. So we went directly in between. We have 2 intervals now, from neg 1 to neg half to 0. They're equally spaced. We're going to draw another number on another interval there. So we go from neg 1, find the midpoint between that. We get neg 3/4. We get neg 1/4 here. So these are our intervals. It says use a midpoint. So this is where it gets a little bit tricky. You're like, okay, so what do I use now? So you use your interval. So you go from this interval to this, so neg 1 to 3/4. Use the midpoint here, and we're just directly doing neg 1 plus neg 3/4 divided by 2, which just gets us neg 7/8. That's it. This is our point. That's our point. And we know our intervals are correct because we can calculate the change in x, b minus a over n. Our b is equal to 0. The upper limit. Mine is usually the bigger number. The lower one is neg 1 divided by the number of intervals, which is 4. That becomes positive, and we have change in x is equal to 1/4, which is consistent since we go from neg 1 to neg 3/4. We're going by 1/4 every single time. And since we know that piece of information, we can see that our midpoints as well are going to shift by the same change in x. So we can go from 7/8. Once you know one of them, you know all of them, because you know this one's going to be neg 5/8, because you're going, every time, you're just going by 1/4. That's it. 2/8. So every time, going down, you're going to have a neg 3/8 and a neg 1/8. That's it. Those are all of your points that you need. The neg 7/8, the neg 5/8, the neg 3/8, and the neg 1/8. Plug those all into the original equation, multiply the whole sum by 1/4, which I'm going to write out for you now. I'm going to erase the number line right there. And we are going to say the area is approximated. The area is approximated by the change in x, which is 1/4 we calculated before, f of neg 7/8. We used 4 intervals here, plus f of neg 5/8, plus neg 3/8, all plugging them into the function neg 1/8. So, and we close the bracket, we solve this, put every point back into the original function, multiply by 1 over 4, we will get an area approximately 0.673, so 0.673. That is the area under this curve, under that curve. So it's if you have a rough understanding, it's going to look something like that, and you're going from what, -1 to 0, and that's pretty much it. So that's, you can plug in the points into this form, into these into the function and make a table. So you go from -1 to 0. You only have 2 points here. You're going to get a 0 here and a 1 there. So nothing pretty much you can graph. That's why we have to use rectangles to approximate this. We used a midpoint Riemann sum here, and I hope you did enjoy and actually learn Riemann sums a little bit better than you did before. So in the next video, I'm going to show you how to do I'm going to teach you the fundamental theorem calculus part 1, since there is another part to that. We are going to do definite integrals and do one more tricky Riemann sum that's kind of weird in a sense. But I hope to see you in there. It's probably going to be the next video after this, probably in a day, or maybe if I feel like in an hour. But my camera wasn't really working. I had to record the video maybe 3 times because the camera was just glitching out or something. But that's the end of this. Leave a suggestion down below for what I should make videos on. Comment down below that. Like the video, share this with your friends. Hope you did enjoy, and as always, nitty gritty out.